This is the function that one of the students did. I want to go through the detail on how to find a critical number before I fill in the table and do a first derivative test for this function. So the function, when you differentiate, using the quotient rule, we'll have an x minus 9 squared on the denominator. On the top, it is low. D high will be 2x, minus high, D low, which is a 1. And we need to simplify. Simplify, not just simplify, but simplify enough to find the critical numbers. It's absolutely necessary. If I expand the first term, I get a 2x squared and then minus 18x. I also get a negative x squared. So 2x squared minus x squared is really x squared. Now you need to factor the numerator because without factoring, it's not easy to find the critical numbers. So now it's easy to find the critical numbers. The critical numbers are the thing that makes this 0, that will be 0. The thing that makes that 0, that will be 18. So it has only 2 critical numbers. But you'll be wondering, how about this number here? The number that makes the denominator 0. That is not a critical number because at x equals to 9, f of 9 is not defined. However, it is still necessary to put a 9 for a vertical line because it makes f prime undefined. So it is still necessary to have nine as the vertical line. So remember that it's not just 0 and 18. We need to put 0, 18, and 9. So let me take another blank page to fill in the table. So this is a blank page. Let me first draw the table. This is my table. And I drew f prime on the top so I can calculate the values that I pick. So remember what our critical numbers are: 0, 18, and 9. We have to put them in order. If you don't put them in order, the intervals will not make sense. For example, if you try to do an interval that goes 18 to 9, it's not going to make sense. It has to go from 9 to 18. Alright, and my favorite test value that I'm going to choose are, say, -1. Over here I can do a 1. Here between 9 and 18 I can choose a 10. Here I can choose a 20. Alright, so this is the part that students get confused. They do not know how to find a sign. Let's start with 20. 20. If I put 20 inside this function, what would I get? I will get a 20, right, times 2 over 11 squared. That's a positive number, isn't it? That's a positive number. So this is positive. Now what happens if I put a 10 in there? If I put a 10 in there, I will get a 10, and then I will get a -8, and 10 minus 9 is a 1, so 1 squared. Would that be positive or negative? Negative. I'm running out of space, so I'm going to erase those things. Oops. I accidentally erased this number 18. How about if I put a 1 inside? If I put a 1 inside, I will get a 1 times negative 17 times negative 8. But it's a square, isn't it? So it doesn't really matter. It's still negative here. It's very crucial that you get this right. The students actually presented it wrong. And lastly, if I put a negative 1, I will get a negative 1. Is that right? Negative 19. And sure, the bottom looks like a negative 10, but it's being squared. Once a negative 10 is being squared, it's just 100. So it's negative times negative on the numerator and a positive on the denominator. That will be positive. So the function will be increasing here. You will be decreasing here, decreasing here, and increasing there. Alright? So the shape of the graph will kind of look like this. Increasing, right? And then decreasing, decreasing, and then increasing again. 9 is actually not a critical number, so you cannot tell whether it's, you cannot even say it's relative mean or relative max, or even neither, because it's nothing. It's not even critical. Only 18 and 0. You can see clearly that 18 is a relative mean, and 0 is a relative max. Right? You write this down in statement form, so it's very, very clear. This table is just a first derivative table for testing.